Did you know that the fastest roller coaster on the planet is Abu Dhabi's very own Formula Rossa in Ferrari World? It reaches a speed of 240 kilometers per hour and it accelerates from 0 to 100 kilometers per hour in 2 seconds. Hello, welcome to another episode of Physics is Easy with Mr. Jesse. In this tutorial, we are going to derive Vf is equal to Vi plus A delta t from the definition of acceleration and analyze the motion or the graph of motion with initial non-zero velocity and derive the equation of motion for position with constant acceleration, that is, xf is equal to xi plus vit plus 1/2 at squared. Now, acceleration is defined to be the rate of change of velocity. So when we talk about rate, time is always in the picture. And when we say change in velocity, that means Vf or final velocity minus initial velocity. So if we are going to look into the definition of acceleration, then we could say acceleration, which is A, is just equal to change in velocity, that is Vf minus Vi divided by time. And we could manipulate this equation so that we will multiply both sides by t, and that enables us to cancel the t here in the denominator. So we will have At is equal to Vf minus Vi. Or, moving on, we could also express this further into At plus Vi is equal to Vf. Rewriting this equation, we can have Vf, or the final velocity, is equal to the initial velocity plus acceleration multiplied by time, and that leads us to the first equation of motion. This time, we are going to derive this second equation of motion given a motion graph. And in this case, the kind of motion graph that we have is velocity versus time graph. Now, you have to remember that when we have a velocity time graph, the area under it is displacement. So let me just write that down. Remember, the area under a VT graph or velocity time graph is displacement. Okay, and when we say displacement, this is just final position minus initial position, so, or the change in position of the object, so that is change in position, or that is equal to x final minus x initial. Now, this velocity time graph shows us an object moving with constant acceleration, constant non-zero acceleration, mainly because the graph is increasing at a constant rate. So here we have constant acceleration, constant non-zero acceleration. So again, this is acceleration. Let me just erase that down. Okay. Constant non-zero acceleration, again, mainly because the velocity of the object is increasing at a constant rate. So now we are going to identify the area under this graph to have the displacement, and displacement once again is just equal to delta x. So therefore, this would be the area of this rectangle here, this area of this rectangle. Let me just shade that. So we will say area of the rectangle plus the area of this triangle here. We will be able to have the displacement by adding the area of the rectangle and the area of the triangle. Now recall that the area of the rectangle is just equal to its length multiplied by its width, while the area of a triangle is 1/2 multiplied by its base and height. So now let's look into the dimensions of our rectangle. So the length and the width of the rectangle would be this. So this could be its length, that, or this. So if we consider this to be the length, so we will have the length is actually vi, because at this point that is vi, or whatever is the initial velocity of our object that is moving at the constant non-zero acceleration, multiplied by the width, which is this side here, and that is equal to time. Plus, we have 1/2. We are now looking into the area of our triangle, and for this triangle over here, for this triangle, the base of the triangle is this side here, and that is equal to t multiplied by its height. So this is the height of the triangle, and here the height of the triangle, we could see that it is actually equal to the final velocity, this height, final velocity, minus this height, so minus this height. Then we will be able to get this height over here. So that would be final velocity minus the initial velocity. Now recall from the first equation of motion that this quantity over here is actually equal to at. So we have at is equal to vf minus vi. Hence, I could write this entire equation, delta x is equal to vit plus 1/2 t multiplied by at. So instead of writing vf minus vi, since I know that vf minus vi is actually equal to at, then I could write at, and then simplifying this further, I can have delta x is equal to vit plus 1/2 at squared, and therefore we have just derived our second equation of motion. So if you are going to expand this further, remember that delta x, or the displacement, is just equal to x final minus x initial is equal to vit plus 1/2 at squared. And that concludes this tutorial. Once again, always remember, physics is easy with Mr. Jesse.